Welcome, geometry students, to Area of Regular Polygons. This is a Kuta software worksheet. A lot of geometry teachers give this type of worksheet, particularly this one, for a geometry course. So let's go ahead and get started. So the first thing that we need to know about regular polygons is that they have all sides and all angles congruent. So all sides congruent and all angles congruent. We'll do angles like that, congruent. So the formula for any regular polygon where these two conditions apply is the area, let me change this to red. The area equals 1/2 the perimeter, let me write that out, perimeter, times the apothem. Now the apothem, it sounds like a weird term, but essentially what it means, it's the distance from the midpoint of a side perpendicular to the center of the shape. Okay, so if we take a look at, it's not letting me zoom in. If we take a look at this 1, 2, 3, 4, 5, 6, 7 septagon here. Okay, so this is the midpoint of a side, and it's, I think it says it's given that that has to be the apothem. Okay, so all these sides need to be congruent. All the angles need to be congruent. This apothem has to be perpendicular to the midpoint of a side. Okay, and then the perimeter is just all this, the sum of all the sides. Okay, so here we have 13.9, and we would add this 3, 4, 5, 6, 7 times. Okay, so the process here for the formula would be, let's use blue. The area equals 1/2 the perimeter times the apothem. And I use a lowercase a and uppercase p for the perimeter. The perimeter is the easiest part to figure out most of the time. You just take the side and you the side length and you multiply it by the number of sides. So in this case, it's 13.9 times 7, which gives us, I'm going to write this in parentheses, 97.3. Now my apothem's already given, 14.4. So now I just need to multiply all this together, 14.4 times 97.3 divided by 2, or times 1/2, and I get 700.56. And that's my area. I need units, so I'm going to write unit squared because it doesn't give us like centimeters or inches or whatever the units are. All these problems here, 1 through 6, are identical. They give you the side length, they give you the apothem. So to find the perimeter, you take the side length and you multiply it by the number of sides, and then you multiply that by the apothem, which is given, perpendicular to the side, and then you divide that by 2, and that's the answer. Same thing through 7 through 10, so let's just do an example. Let's do the octagon, because that, I guess, looks a little tougher, but it's not much. So the side, so area equals 1/2 p times a, 1/2 the perimeter, so we're going to do the side length times the number of sides, 8. So 11.7 times 8, that's 93.6. And then it gives us the apothem, 14.1 times 14.1 divided by 2. And I get 659.88 units squared. So 7 through 10 are the same deal. So they're pretty straightforward. Number 8, you're going to want to leave in terms of a radical. That's how I would ask for it to be expressed as a math teacher. Okay. Now we're moving on to some tougher problems. Use what you know about special right triangles to find the area of each regular polygon. Leave your answer in simplest form. So here's the deal. We have this distance here, but that is not the apothem. Notice how it is not perpendicular to the side. Okay, so we really want that distance there, but we don't know what it is. We are also missing another key piece of information, and that is the side length. So we're missing some very important things here. Now, the key to these problems is that for all these regular polygons, the angles are all the same for each triangle. So this is, for each shape, they're all going to have congruent angles. So that's 60, that's 60. The third angle is 60, but this is splitting it into 2. So this is going to be 30, and this is going to be 30. Now, this is 30 right here, and this is 90. That means this angle has to be 60. Now we have a 30, 60, 90 triangle. Let me do like a zoomed in view of this perspective. Oops. Get my triangle, and there we go. Okay. So this is 30. This is 60. So what I like to do first is I like to label which side is the shortest. This is clearly my hypotenuse over, let's make it green. This is my hypotenuse. My shortest side is going to be, this is my shortest side, short. And this is my medium side, medium. We already given the hypotenuse, which is 18. So the easiest side to find is in fact the shortest side. So the rules for 30, 60, 90 are that you take the hypotenuse and divide by 2 to find the shortest side. So we're going to do 18 divided by 2, so the shortest side equals 9. So now we know the length of our apothem. That's not enough though. So we also need to know the length of the side. How do we do that? Well, from the short side, so we did divide by 2 here, divide by 2. From the short side to the medium side, we multiply by radical 3. So we know that this part of the triangle is going to be 9 radical 3. Now that's not the whole side though. That's only half of the entire big triangle. It's the whole medium side for the little triangle that we drew inside, but it's only half. So we need to multiply this by 2 to get the whole big side, and that ends up being 18 radical 3. Now we're ready. We're ready to apply our formula, which says, let me use, I don't know, let's use this brown color. We know our formula for the area of a regular polygon is 1/2 times the perimeter times the apothem. So we're going to go ahead and we're just going to figure out some of these things. The apothem we already know is 9, but the perimeter we need to multiply by 3. So we need to do 18 radical 3 times 3. So 18, so we get 54 radical 3. And we multiply that by the apothem, which is 9. The first thing I would do is I would do 1/2 times 54, because I know that's 27 radical 3, and then multiply that by 9. So I do 27 times 9. That gives me 243 radical 3. That's units squared. Personally, I would not be looking for decimals, so don't even try to use decimals. Your geometry teacher is going to want to see you apply the rules of a 30, 60, 90 triangle and have it in terms of the radical. It's really important to be able to manipulate radicals, so I would leave it like this if I were you, okay? That's pretty important. Now, on a side note, for an equilateral triangle, if you were to, there's a shortcut for this. So let me real quick explain it. I'm going to explain it in more detail in another video. But because this is 60, if you drew the height, the area of a triangle is 1/2 base times height. We know the base, we could call it S. So side, so what area equals 1/2 the base. Whoops, sorry, that was 3. 1/2 times the side, that's the base. Now the height, what would the height be? Well, this little part would be, let me zoom in. I don't know why I'm going so far away. This little part, if the hypotenuse is S, and this is 30, then this would be S over 2, leaving the height being S squared of 3 over 2. All I did was multiply by radical 3 to this half segment here of the whole side to get my height there. So then I multiply this by S squared of 3 over 2. Combining all this, the area of an equilateral triangle, and this is true always, is S squared of 3 over 4. So you can find the area of an equilateral triangle just with the side using this formula. So if I were to plug in 18 radical 3 into my formula here, and then square root of 3, and then over 4, you'd get this same answer. So that's just a quick side note on area of a equilateral triangle. Let me do one more. Let's do one of these ones. So let's use the quadrilateral one. Yeah, let's go ahead and do quadrilateral. That'll be a little bit quicker. So the quadrilateral, so if it's a regular quadrilateral, that means it's a square. So I'm hoping my notability can recognize that I'm trying to draw a square here and help me out. There it goes. Okay. Now I know it's saying my radius. That's the distance from the corner to the middle. Saying my radius is 16 radical 2. So the important thing to find the area of a square, we know the area of a square, we could do a couple things. We could use the apothem, which I guess that's fine. We could do perimeter times the apothem. Or we could just find a side length because we know the area of a square is side squared. So what I'm going to do is I'm just going to go straight to this, trying to find the side of the square, okay? So if that's also another radius, and I'm looking for this purple distance, that's why I drew this other part of the triangle. I have 90 degrees here, and this is split because these are 90, and this is 45. So this is 45, 45, 90 reference triangle. Sorry, and I want to be I'm a little perfectionist here. Okay, there we go. So then this is the side, and I know the relationship is the hypotenuse is side squared of 2. So I need to multiply this side by radical 2 to get the hypotenuse, or the side of the square. So I do 16 radical 2 times radical 2. Well, the radical 2 times radical 2 is going to be radical 4, or 2. So I get 32 for my side length. So I know the side of the square is 32. And now I can just plug it into this formula. Area equals 32, or if you want, you can do 32 times 32 is the same thing as 32 squared. So then I do 32 times 32. Give me a second. 32 times 32. I get 1,024 units squared. If you want to find the apothem of a square, I'm not going to stop you, but just know that it is this distance here, which is half the side length. Okay, so half the length of the side of the square, this distance right here. So this is going to be 16. If the whole side length is 16, then for a square, the apothem's always half the side length. So that's 16. Okay, hope you found this video helpful. You should be well equipped to handle any regular polygon problems. Be sure to leave a comment if you need more help on any particular subject regarded to area of regular polygons or area of equilateral triangles. And I hope you have a great rest of your day.